Okay, good morning. Norsk olje og gass, or Norwegian oil and gas, for those who are not fluent in Norwegian. The association of all the operators and a few of the main suppliers to the oil and gas industry. Myself, Roald Sirevaag, my day job is to be a manager for subsea technology and diving within Statoil. And then in addition, I've had the honor of being the chairman for this network for the past about 5 years. This presentation has actually been put together by David Llewellyn, who is the facilitator for NOROG on these issues. He's sitting here. So if your company is a member of NOROG and you'd like to get involved in what NOROG is doing within the subsea installation network, you can contact David or myself and get involved. We have normally 3 meetings per year, next in May. This slide you've seen, these are the companies that have been involved in this work on standardization. It actually started with what was called the ORM report, which pointed to things that could be improved within oil and gas. It was made a bit more concrete by the Concraft initiative, which also pointed to some specific issues within subsea. And then NOROG Subsea Installation Network took the challenge of working on those specific items, those related to subsea. And these companies were involved. We split up in a number of work groups. Not all companies were involved in all work groups, but some participated on something and some on all. And okay, here you have a picture of a subsea facility sitting on the seabed. And those work groups, they talked a bit and discussed a bit back and forth. And they decided that in total there were 6 things we would like to look closer into. One was the specifications for the forgings, the steel materials used in pressure containing equipment. Second was to look at this concept of a configurable standard, a universal workover system. If you're going to do some serious workover on the well, go in with coiled tubing, produce the well back to the rig, you need a workover system. Standardized documentation, brownfield re-engineering, quite complex matter, but there are some best practices that can be adhered to. And then the internal compliance within particularly the oil companies. There are a lot of creative engineers, and to get some compliance to the guidelines within the companies, that's a tough challenge. So I'll go into each of these 6 as the presentation proceeds. Standard work in Norway, Jens Henrik Neunkirchen has talked at length on that, so I'll skip this slide. Forgings, the steel for the pressure containing equipment. Each of the major oil companies have their own specification. A pilot project was put up looking at what Shell, what Exxon, what Statoil had in the detailed specifications, looked across these and found there are actually no irreconcilable differences. It should be possible to make a common specification based on this. And the idea came up that it could be arranged in 3 grades: standard for non-hydrocarbon service, plus for static applications, and premium for fatigue-sensitive applications. And with this assumption, DNV got involved, thought this is a good idea for recommended practice, set up a work program of what things to look at. And this was informed about in a number of fora and was actually quite well received. And as of today, there are 19 companies involved in this work. There's a group of operators, all the main EPC contractors, and quite a few of the steel forgings suppliers So they cooperate in this JIP, and there are sub-arenas for discussions between the operators, between the contractors, between the manufacturers. And the intention is to come up with a recommended practice by the end of this year. And ExxonMobil is actually one of the really drivers for this. They see the business opportunity for standardizing the forgings, because then every aspect of the forging is known, and the vendors can go to the forge masters and ask for this and pre-stock them. Subsea component catalog has been mentioned a few times. It's a set of building blocks, a structure, a manifold, a Christmas tree system, a control system, tooling packages involved. And you configure it to the seabed conditions, to the reservoir conditions, and to the host that you're tying into. So because every reservoir and field situation is different, so you need to do some adjustments and configure it so it fits to the reservoir, to the seabed, and to the host. This report was actually finished like third quarter last year, so there has been some thinking done following on that. And cars were mentioned as an analogy here earlier from DNV. And so this slide was not part of the original package, so this is not a NOROG slide, this is more Statoil or my slide. So with respect to cars, you may say there are different segments. You have the family van, the station wagon, the Volvo maybe. Volvo isn't mentioned here, but okay, then you have cars for youth, for seniors, and for those adventurous people who would like something special. And each of the big suppliers of cars, they have a model to fit each of these segments. So the main point here is, yes, there are segments. So don't get hung up in what car is mentioned in each segment. I have a young colleague who drives a Tiguan, and he's not happy that he's considered a senior citizen. So that's not the point there. And if we then transfer this to Subsea, and we have the Aker, FMC, GE, and OneSubsea of this world who are the EPC suppliers. And if we then say what the solution we use for the Norwegian continental shelf, what Saga and Hydro and Statoil each decide was useful, and which Statoil is using now, these 4-slot templates, and also the 1-slot satellite. Template solutions because of the overtrawlability of the Norwegian continental shelf, 7-inch because of high yield reservoirs, 10K because most of the reservoir have shut-in pressure below 10K. Most of the reservoir have temperatures below 121 C, which is this in Fahrenheit. And the water depth here is normally between this. So this solution fits for, let's say, 80–90% of the fields on the Norwegian continental shelf. And then internationally, ideally, we could manage with 3 solutions. All clusters, one 10K, one 15K, one 20K, with a temperature range associated with this. And what's happening internationally, most things are happening in 1,500 to 3,000 meters. So if we as an industry and as operators could agree on something like this, that would be really useful, because then each of the vendors could have their model in this segment, and they could compete for every time things are being tendered. And with respect to whether this stifles innovation or not, the Golf, I don't know, is it on the 6th or 7th generation? The Golf as a concept and as a model survives. And the solution here would survive and evolve as technology evolves, as long as the model and the concept itself is good enough. So it would take care of technology development as well. There is no potentially being established an OGP, oil and gas producers subsea network. So we have kind of a test meeting in London on April the 7th. And this is one of the things I'd like to present there as an idea. Could we as an industry agree on something like this? And most likely, from Statoil's side, we would volunteer when we have now developed our next set of specifications. We have a standard that we're using today. We're using it on the 12 fast-track projects. We are developing a new one based on vertical Christmas tree. This should actually say vertical Christmas tree on all these, with tubing hanger spool on these ones, probably. We would most likely say, okay, this is available. We will publish this. This process is maturing in our head now, but I have had no I've had no resistance so far. Because then everybody who'd like to have something similar could take this, which is called Exhibit E in the contract, could go to the 4 vendors and say, what's your answer to this? And they say, okay, our answer to this is Exhibit I. And then everybody, Lotus, you're still here? Yeah. Lotus could use this as Exhibit E, which is the formal foundation then for the contract. The vendors would answer with Exhibit I, and you could have something, the same thing. And again then, if the Chevron, Exxon, BP of the world would come forward with their specifications for these, or OGP as a group could agree on these specifications, okay, it's a kind of radical idea, but it may work. So I mentioned this in a meeting with Houston on the SPE, Society of Petroleum Engineers, last week. I'm sorry. So they listened, and I was quiet for half a minute, and then they started talking about welding specifications again. So it takes some time to really sink in and be open to it. Interfaces are important. To be able to connect things, you need to have defined the interface between the main components. And the connection of the umbilical to the subsea station is one such thing. And as of today, each of the 4 vendors have at least one solution for the umbilical termination head. This is not an umbilical termination head, but okay, you get the idea. What we think now that maybe we should have, sorry about this, 2 small buttons. Umbilical termination assembly that is landing just next to or just onto the template or to the manifold. And if we can agree on the size of this thing and the type of connectors to be used for the MQC plates and for the single connectors, we could standardize that interface and make the complete umbilical length, define the interface towards the template, and also define the interface towards the marine installation contractor, so that those 3 things could go independently and not waiting for the subsea supplier to come up with this interface before the marine thing could be handled. There are some further opportunities, just some ideas that have been invented. There's good work being done on the electrical high voltage things in a JRP called SEPS. They have just finished a specification for connectors and penetrators. And there are some other ideas out there which are being looked into. As mentioned, if you need to do some serious work inside the well or flow the well, you need an LRP type workover system. And traditionally, for each generation of subsea permanent installed equipment, there has been a version of the a workover system. And each of the vendors have had their systems, which have been unique. So for Statoil, we ended up with, I think it was 20 or 25 sets of such equipment. If you buy a new set of equipment today, it costs 500 million each. And some of these are 20 years old. And every time you need to go into a well, you need the dedicated system. And that's really not efficient. So we made a design of a universal system with adapter on the bottom here, and with the control system with the necessary flexibility, so that you can use one system and have that allocated to a rig. And whether you're going on a GE wellhead or an ARC or an FMC or one Subsea, we have very few of those for the moment, you could use the same system. So Statoil has 5 of these systems on order, starting to use them now. And it will make the well intervention very much more efficient. And others could cooperate to have systems they share between them. Documentation. Again, with the car, when you go and buy a car, you get the manual. Basically, what the oil companies do when they buy a subsea system, they say, here's our manual on how to write the manual. And the manuals get very expensive that way. So the question here is, could we design on some minimum data sets and a menu and a structured way of organizing this documentation? And again, DNV picked up on the idea and initiated a JIP, and these companies have signed up to participate in seeing if it's possible to generate a standard recommended practice for documentation. Brownfield subsea re-engineering. 2 minutes left. Okay. Well, a field lasts for a long time, and you buy equipment many times. And what Shell has seen is that, okay, for those 22 subsea wells, they have equipment from 3 suppliers and 7 3 designs. And if they need some more equipment, they probably get a new version. So you need to apply some good practices here on how to take care of this. And I will not go through them. But this report is free. This NOROG report is free, so if you contact David or myself, you can get the copy and you can read what's needed. So I'll skip this. Compliance. Yeah, okay. We are all good engineers. The reservoirs are different, the seabed condition is different, the hosts are different. In every case, there is a reason to do something different. But again, back to the cars. Every road is different, every driver is different, but the cars are still the same, okay? So we need to be able to handle this. Equipment qualification. Equipment qualification takes quite some time. And we need to do it before sanctioning of the projects, otherwise the execution phase is not for the faint-hearted at least. So there are some ideas of what to look for, and this was generated at an FMC conference a month back. Okay, in Norway we don't need 4,000 meter, we don't need extreme HPHT, but a few of these others are relevant for Norway. So we need to get together, we need to get our act together and pinpoint which are the most important ones and get going. Okay, conclusion and way forward. The NOROG work has helped to get these two JIPs on the road. Looks promising at the moment, at least for the first one, hopefully for the other one as well. And there are some recommendations, basically the things I've been talking about for the other points there. And NOROG will work to motivate and align forces and initiate things within this domain to get things going, because we need to get the cost down on the subsea equipment. Our management said so, and it's a fact we need to do that. Okay. Thank you.
Thank you. A really interesting presentation. Is there any questions? Throne is ready.
Thank you, Roald. Very good. I don't think it's on there, but I'll speak up loud. Oh, sorry. Norwegian Oil and Gas is an owner or a supporter of Standard Norway. And to me, some of these activities are partly competing with Standard Norway. How do you look at that? You get a lot of people involved, a lot of companies involved, while in the standardization organization, it's more challenging to get people involved. Do you have any comments to that?
Okay, I'm not aware that we are competing. Hopefully we are fulfilling each other, more to say. Well, standardization work, the problem with standardization work, as Jens Henrik said, is that ISO has grind to a standstill. So you actually get nowhere. You can burn a lot of effort and you get nowhere as the situation is today. That's the basic problem. And my personal opinion is that, okay, NORSOG did its job for a period, but that period is done. So we need to get the things that we want into the standard. We need to get that into either ISO or RPE, and ISO should be like this. So, okay, I don't know if that... David would like to add something to that.
Yeah, I think you could consider this work as setting the context for Standards Norge. So in a way, we've had a strategic view of what the subsea industry needs to focus on. But there's absolutely critical that Standards Norge picks up the detail of what we're recommending, the RPs, the welding specs, the documentation spec, and moves them through into ISOs or API. So I think what we were doing is saying these are important, we need to work together, take delivery of the recommendations. I hope that answers that it's not competition. In fact, we've always been cooperating. All this has been presented to Standards Norge in their committees, so there's been no surprises on either side. Yeah. In fact, Jens Henrik is in both groups. So I would like to make that point. Second point, quickly, I'd like to make is in this whole effort to industrialize the subsea sector, I think we have so many challenges in the subsea arena with the subsea factory, long tiebacks, the Arctic, subsea processing, compression. We need to move the engineers who are currently working on templates and standard Christmas trees onto these new challenges. There's a limit to how much competence there is. Let's standardize and routinize what we do normally, trees, templates, tiebacks, manifolds, and get the talented guys moving into the real challenges for the future. So hopefully we can release some energy towards those new challenges through this program of work. Thanks.
Thank you.
Thank you. Just a comment. I've been in both groups as well, and I appreciate the work Norwegian Oil and Gas does and OLF Subsea Installations Networks. Very good. I'm just questioning if it seems to be very easy to get resources into the JIPs that you're running, and we know you did a tremendous job on subsea leak detection. Very good. But then there are other issues, wellhead fatigue, which ended up in Statoil, which maybe is a challenge that Norwegian Oil and Gas should have taken. I know they were involved, so I'm just questioning. I'm not saying that it is, and I'm over-exaggerating a little bit, just to provoke a little bit. But
Okay. I don't have all the answers, so maybe that question should not just hang in the air.
Okay, thank you for that. Any more questions? Okay, then we say thank you to Roald.